I wanted to look at some interesting advances in technology. Smartphone integrated CRISPR biosensors for portable and high sensitivity diagnostics was the title of an article from Sci-Fi Forum's publication. And the abstract begins by talking about the combination of CRISPR-based biosensors with smartphone technology and how it's changing the point of care diagnosis. In the first paragraph, they tell us electrochemical and field effect transistor-based biosensors and quantum dot assisted fluorescence has been used to enhance the sensitivity and accuracy of the signal. The lab-on-a-chip microfluidic platform has been integrated with diagnostic devices to achieve automated and multiplex testing for high throughput and low-cost testing strategies. This is the one I want to look at mostly. It is from January 2020 as the last revision date. The title is Futuristic CRISPR-Based Biosensing in the Cloud and Internet of Things Era, an overview. Your abstract, it says, this review focused on the use of machine learning approaches for the development of futuristic CRISPR biosensors based on microchips and the use of Internet of Things for wireless transmission of signals over the cloud for support decision making. Looking at some of the highlights of this article, it says the use of nanotechnology for design of nanoscale devices, so this is a very small device, such as nanochips, nano interface, nanosensor, nano routers, and nano antennas in different fields such as healthcare systems, electronics, agriculture, etc., stimulates the concept of Internet of Nano Things. And just a quick side note, in 2020 at the 5th Annual Applied Science and Engineering Conference, they discussed the integration of animal tracking and health monitoring systems. Zooming in a little bit on that one, the animal temperature monitoring system and location tracking system based on global position system and short message services gateway is one of the effective solutions to solve problems in detecting the health level of pets and to decrease the amount of pet loss cases. That system uses GPS technology installed on the animal's body. While that one might be for livestock tracking, it doesn't seem out of the realm of feasibility that it could one day be used on humans. At this conference, they discussed that the horse had a chip implanted on the left side of the neck just below the mane. Birds were usually marked on the chest. The RFID technology-based health monitoring system can be used to detect various parameters of animal health, such as heart rate, body temperature, and animal ECG. The next paragraph actually mentions humans. It says the use of GPS technology is a technology commonly used to detect the presence of animals or humans. And several pages forward, graphene as a nanomaterial is mentioned. This article is available for purchase. Under the proposed biosensor, we're able to see some of the difficulties they must overcome. Big data information collected from monitoring of patients' health using biomedical sensors require algorithm optimization and high computing power to reduce energy consumption. One of their challenges in cloud computing applications is the data storage, accessibility, and management of health information. They go on to say the entire power platform of cloud computing is underutilized, and thus the use of biomedical data, IoT, meaning the Internet of Things, and cloud computing will open a gateway and form a basis on our proposed CRISPR-based biosensor. Keep in mind, this proposed CRISPR-based biosensor in this article was originally discussed in January 2020 when this article was updated. Living out in the country, I found this statement under conclusions quite interesting. It says the majority of outbreaks of diseases, i.e., epidemics, affected the remote and rural communities with low access to medical diagnostic tools and equipment. Jumping forward a bit, it says the application of IoT, big biomedical data, cloud computing, artificial intelligence, and signal data obtained from CRISPR based biosensors or nanobiosensors will provide clinical data in the cloud computing system. And it goes on to talk about the people who are able to access it. They say to achieve an ideal, smart, and futuristic biosensor, so many challenges must be addressed, such as increasing the sensitivity of the biosensor, complexity and privacy of biomedical data, fabrication of biosensors for use as the POC, meaning the point of care, molecular diagnostic tool, power consumption, coupling biosensors with wireless technology, and developing multiplexing biosensors for the detection of different pathogens. And while the information is now 5.5 years old, the lab on a chip is possible to be created with microfluidic devices with features that can be injected or implanted, according to a Google search.